Okay, lab 5, magnet in a tube. All right, so the purpose of this lab is to observe a magnet that's falling through an aluminum foil tube and apply Faraday's law to find out stuff about what's going on. Principles, we got, magnetic flux, Farad law, Newton's laws, Faraday's law, all the good stuff, really. The computed time 1.024 seconds, and the experimental time was 1.21 seconds. Okay, and the model, we got a typical dipole magnet with a typical dipole magnet field. We assumed that air resistance was negligible. We assume that we're on Earth, so gravity is like normal. And we also assume that there's no outside magnetic fields other than the magnet and what happens from the aluminum tube experiment. So the system is a magnet and the aluminum tube. Surroundings is everything else. And so the procedure, I measured the tube, got the measurements for the tube and stuff, and I determined which side was which pole for the magnet, and then I recorded myself dropping the magnet through the tube 5 times, and I used the videos to determine how long the magnet took to fall through the tube. These are my measurements. These are my times. Um, yeah, you can read them if you want. They're pretty boring though. Questions. Some interesting questions here. Why can't we use a Ferris tube like a steel pipe? Good question. That's because Ferris tube would be slightly magnetic, so that would mean that it would interfere with our experiment. What happens to the magnet? How does it compare to a magnet falling in free space without a tube? Basically, the magnet has a force put onto it, so it falls slower because it's like converting some of that energy into like current. Yeah. This is the glow scripts. Got a lot going on here. Define some parameters. Then we create the tube. Then we create the bar magnet. Um, and then we calculate the magnetic field for the bar magnet. And then we calculate the flux from that. Um, and then, yeah, that stuff. And then calculate the gravitational force on the magnet. Then the force from the tube on the magnet. Then the flux, deflux, dt, and then the current, and then each ring, coloring them, and then we computed the B field at each ring. Then we just got the magnetic force on the magnet. Then we got the net force on the magnet. And then from that we got pretty much all the information we needed. So here's some crazy questions. The intensity of the coloring on the tube indicates the magnitude of current flowing through each ring. Red and blue indicate current flowing in opposite directions. Which color corresponds to the clockwise current as viewed from above, and which is counterclockwise? So, as viewed from above, the red, the North Pole, is going to be counterclockwise, and the blue is going to be clockwise because of the right-hand rule and the direction, and it opposes the direction of the flux. Well, what happens to the dynamics of the systems when you flip the magnet around? Basically, the same thing would happen. It would have, resistance. It would fall slower. It's just the current would go the other way. What is the total time in two of your real world system compared to that of your computational system? The total time in cube of my real world system is it was in there longer. Um, in my computational system, I don't think it could be more accurate. I think it's just about perfect. What is the shape of the velocity versus time plot tell you about the forces acting on the bar magnet? It tells you that as soon as it enters the bar, the forces are kind of unbalanced, and then it equals out, and the velocity remains constant. Model discrepancies, none. Sources of error, there might be some air resistance that I didn't think about, as well as just like human error with my timing and my mu. What if the resistivity of the conductor was reduced as close to as possible to zero? How do the dynamics of the falling magnet change? So basically, it would convert more of that energy into current, which would mean the magnet would fall slower. Or that's if you ask me. I think that's what happened. What if holes or slots were cut into the tube? Another great question. I think that would reduce the current because it would like disrupt it, and so it would be flowing slower, and then the magnet will fall faster. Oh yeah. Thanks for watching.